This is a revision and overview on functions. In this video we will look at the following topics, and where the blue is grade 11 work and the purple are grade 12 work, although at the end of grade 12 you will be examined on all of these topics. So for the instructions, make your own notes and summaries throughout the lesson, so that when you start working through past paper questions and get stuck, you will have a quick way to refer back to the methods and steps on the specific question. And when you see this button, you have to pause the video first and attempt the question on your own before watching the explanation. To get started, we start with the properties of the graphs. Now these are the four basic functions that we will be working with in grade 11, and it's the straight line, the parabola, hyperbola and exponential. Now these are the standard forms and the standard equations that you should know of by heart. The properties of the straight line, so we have the m value and a c value. So the m value is the gradient, and what the gradient tells you is the slope of the function. So the higher the gradient, the steeper the slope will be. The lower the gradient's value, the less steep the gradient, the slope will be. Now this is the formula for the gradient. If you have 2 points on a straight line, you can substitute these 2 points into the formula, and that will give you the gradient. And then if the gradient is greater than 0, the line will slope to the right, and if the gradient is less than 0, the line will slope to the left. And then the y-intercept, this is the c value, so that shows this value is where the line intercepts the y-axis. So if this c value moves the straight line up, or it moves it down. Then for the parabola, now the parabola can be written in one of 3 forms. This is the most common form, this is its standard form, and then we can write it in completed square form. Now what this completed square form shows is this p value, this p and q value is over here. So this is your turning point, which we will deal with later. Now that's when you write it in this form, it's very easy to find the turning point. Now if you do not know how to complete the square, you can go back and do these 2 lessons on completing the square, and then also we can write the parabola in this form. Now this is if it can be factorized. If you can do trinomial factorization on that, then what this form shows you is where your 2 x-intercepts are. So this is the x1 and x2. And if you do not know how to do trinomial factorization, you can go back and do these 2 lessons. Alright, and then for all 3 of these we have a values. Now if the a value is positive, then it slopes up, and if the a value is negative, the graph will slope down. Then for the hyperbola, we have it in its most basic form. It looks like this. Now if the a value is positive, the hyperbola lies in quadrants 1 and 3, and if the a value is negative, the hyperbola will lie in quadrants 2 and 4. And here we have its completed form. Now we have this minus p that comes in and plus q. So what the q value does is it moves the graph up and down. So if this is plus 2, say, then the graph moves 2 units up, and when it's negative 2, it will move down 2 units. And notice how the asymptote moves with the graph, and then if we have this p value, it moves it left and right. But you have to be careful, because this standard form has a negative over here. So when you move your graph to the left, it has a negative p value, but because a negative times a negative will become a positive, it will look like in the standard form, or in your formula, if you have a plus b, the graph will lie to the left. If you have a minus b, the graph will lie to the right. And then for the exponential, so in its most basic form, it looks like this. It goes from the left-hand side up to the right-hand side, increasing. Now, what happens is if we reflect this line in the y-axis, it looks like this, and therefore the x will change to a negative x. So this will be the standard form for the line that increases to the left. And then if we reflect this line in the x-axis, this will be the standard form. So what happens here is you will, when you reflect it in the x-axis, the y changes to a negative. So we will have something like negative y equals to ax, taking that one, just reflecting it in the x-axis. And then when we solve for y, we're left with minus ax, and that's where this negative comes from. And then finally, reflecting it both in the x and y-axis, both these negatives will be before the a value, before the first term, and the x will be a negative x. And then finally, for the a value, if you have your a value, this is the effect that the a value has. So the higher the a value goes, the steeper the exponential graph goes. And then the effects of the p-value. So we have the p-value over here. Now see, when our p-value is negative, it moves to the left, and when the p-value is positive, it moves to the right. But because our standard form has a negative over here, in the standard form, if you have a minus in your equation, the function actually moves to the right, and when you have a positive, it actually moves to the left. Then the effects of q. So when q is negative, the graph goes down. Notice how the asymptote moves with the graph. And when q goes to positive, the graph moves up.